Fran Ayala, professor at the University of Murcia. He is expert in injury prevention in soccer and also in women's athletes. He has worked a lot with international researchers. He's well known in the world of research, and I think that it's very interesting and a little bit different than the previous lectures or presentations to explain some about their research lines.
First, I would like to thank Miguel Angel for the opportunity given. I'm going to do a brief overview of what we are doing here in Murcia at the Faculty of Sport Science. In terms of injury prevention, we have two main objectives. The first one is to build model to predict injuries. So we are looking at developing some model that allows us to identify the probability of sustaining some specific injuries, not only in elite soccer, but also in youth soccer. And currently we are working on women's soccer as well. And we try to apply some specific techniques, such as machine learning, in order to get more robust prediction scores. And we would like also to develop some model in order to, I could say, identify the biological responses that a soccer match leads in player. And we would like also to identify the recovery process, how we can manage, how we can predict if a player will get full recover in 2 days, 3 days, and what is the pathway. So what we do, we try to assess a lot of things because we are aware of the fact that the injury is a multi-component phenomenon. So we not only try to test motor performance and neuromuscular capacity, but we also want to identify, to assess, to test players' visual performance, player cognitive behavior, and also we try to include in this model some contextual factors, because we think we need to include all of these features, all of these aspects in a model in order to get better results. So we have spent several years in trying to learn and develop some specific tests. For instance, we have developed some test batteries to analyze range of motion, isometric strength, and we are also working on analyzing some movement competency metrics, basically jumping and change of direction. We analyze all of these things 2 or 3 times during the season. And when we have all the data, we have a very long code of algorithms, and we analyze and learn some model because we want to forecast the or modeling the risk of injury. For us, it's something that we only have in our mind is the simpler the better. So our models are always trying to reduce the number of features coach have to assess if they want to run our model. So before building a model, we apply some feature selection algorithm, because we are conscious that in a applied setting you only have 1-2 hours. If you want to test on the player, we need to be aware of that, and we try to select the most relevant or the most important feature or variable in order to be at least a moderate accurate. You want to predict in the future some injuries. Here there is one example of our model. We use the efficient tree algorithm, and here this is an example. I think our colleagues from Australia are great experts on that. And with this type of model we can predict some injuries. For instance, we have developed some model for hamstring and hamstring injuries, and this is one of them. Our ability to predict this type of injuries, I think, is higher. Is 0.8 area under curve, which is a great result, but we want to improve this. Um, this is a chart where you can see how we organize the importance or the prediction ability of each feature and how they can be scaled. We have some algorithms that help to do that. So in some model, we don't have to measure more than 250 variables because we have done some feature selection processes. Some models are composed by 10, 12 features, so we can promote their use in applied settings. This is one example of a model that we run with some field-based tests, and by using just 12 uh, variables, we can predict some soft tissue non-contact injuries, in that case, in used pliers. So, which is fun, it's fine because we don't have much time in during a season, and this is an example. But we are also quite interested in how to understand or understanding the relationship that may exist between the factors that are involved in the likelihood of sustaining an injury. So we use, in that case, Bayesian network. Uh, Using this graph help to at least figure out how the different factors interact among them. This type of techniques also allow us to make abduction, I mean, make predictions what could happen if we change some variables. This is something that here in this audience, there are some experts in machine learning can speak better than me, but we are also interested in the relationship, the type of relationship we we can find between or among these factors, because in terms of training, we need to know how they can interact in order to design tailored programs. So this is something we also are working on that. And when we have this model, we are trying to translate, to move what we are doing in our research group to the field. And what we do, we try to do some reports for athletes because we receive athletes for the local club, and we write some report. I have an example of this type of report. So we try to help coaches to understand what we have found in our testing. So we use our techniques to let them know what is the probability of sustaining an injury. In that case, 35.9%. And we also try to give some specific report for each test, just for them to let you know how players are. And well, this is an example of what we are doing with the local clubs. And we're also trying to developing or to design some digital picture, we said, because we want to help coaches to use our model. Of course, we know that we need to develop APPs, and we are working on that because we need to make coaches to use our model in a very user-friendly way. And we're also designing SSA-based programs for them to at least improve the physical condition of their player. And this is an example that we are doing now. We have developed some, I could say, exercises for the coaches to pick according to their player physical characteristics. And these exercises are for grassroots coaches, and they can use them in their training day and just apply it to their kids. In that case, a way of improve the kids' motor competency. And we have in different idioms with different characters, and they can be used in everywhere. And in the future, what we would like to do, we would like to improve our model by including data collected every single day from the player. I mean, we have the technology now to collect, for instance, every single day heart rate, GPS data that in elite team they are collecting. And we would like to add this data to our model because our model our model are made by using data collected from 2, 3 different time points through the season. And it could be great if we could include more data in order to get them better in terms of prediction abilities. And we would like also to move from group-based model to individual or project-based model. I think we can develop a model for a player instead of develop a model for a group of players. So if we can collect several longitudinal data, we can reduce this inter-individual variability by focusing our model is just one player, one model, like an avatar, I would say. And this is our challenge for the future. Try to focus our attention on how a player reacts against different stimulus in their daily basis and how we can update the model every single day because we can get data every single day. So this model is would be the dynamic. So it could be improving every single day. So we have smartphones, GPS, and so on. So we can try to move to that pathway. We also are looking at how player respond after a match or after a training session because we want to predict these responses. For instance, we have done some pilot studies, in that case, in basketball player. So we wanted to predict the player internal load based on the external load. So we ran some model, and finally we got one against Bayesian network. And here we can predict what would be the player internal loads based on the external load. So in that case, we wanted to analyze what could be the reaction of a player if we organize or we plan a training session with some specific physical demands. We can, in that case, we could predict with a good, let's say, prediction abilities. For the future, what we want also to predict these player responses, but not only based on just the RPA, but also how the muscle damage could evolve according to what player is doing every single day in their trainings. And we would like also to predict, for instance, the muscular performance, um, the cognitive performance according to player fatigue. So this is our plan for the future, also to develop one model for one player and trying to analyze all of these things because we want to monitor the player recovery. A good way to do that is trying to include in that model every single day data to build or design this, I would say, prediction forecasting. So this is what we're working now in trying to predict the player responses to the training and matches in order to design our objective is to help coaches to design some program that could help to players who recover during a week or during a specific time. because we think this is key in terms of injury prevention. I think we are also working on. That's it. Thank you very much for your attention. And thanks, Miguel, again for the opportunity given.